Hello, we are Team 10, and we are replicating the paper Measuring and Mitigating Name Biases in Neural Machine Translation. So I will briefly introduce the problem and the proposed solution, and then my teammates will go through the replication approach and the problems we faced so far in replicating. So the problem basically is in NMT systems, there exist gender and racial biases because our data sets are highly skewed. While training the NMT systems, see far more of one category in the data set than the other, which makes the translation make far more mistakes in one category. For example, it makes more mistakes in female categories while translating. The problem is worsened when we are trying to translate to language which in grammatical gender, and the gender information in the sentence is not explicit. For example, when the gender information is the person's name, the only cue that the NMT system gets is the person's name, and it has to squeeze out the gender information from that, and it becomes much more faulty in that cases. And we also see a similar problem with sentiment biases. For example, in some languages such as Chinese, there can a word can have different connotations, and like our NMT systems, they tend to associate certain names or gender or ethnicity with certain sentiments. Next slide. The proposed solution is called switch entity, which is basically a data augmentation method. It doesn't require us to collect new data, but we can do the data augmentation method in the data set that we have. And basically what we do is for each category, we switch the names of the people so that while training the systems is far more of the people in one category, for example, far more females, so that the machine can learn from it. Now my teammate Tivan will propose the replication method.
All right, so this is the replication approach we took. First, we loaded the WMT18 German to English dataset, and then we copy the dataset and apply entity switching on it. So now we have two datasets to test on. And then we evaluate the accuracy of a pre-trained model applied to each of these datasets. Next slide. And the results of this experiment are as such. On the regular dataset, the pre-trained model on the male subjects had an accuracy of 91%, while on female subjects, it had an accuracy of 47%. And these values are similar to the one achieved on the paper, but they are a bit lower, the reason for which I'll explain shortly. However, on the augmented data, where we applied entity switching, we had an accuracy of 74% for male subjects and 42% for female subjects, which is completely unexpected and opposite to what happens in the paper. In the paper, though the male accuracy does decrease, it is only by 3%, and it is still pretty high, while the female accuracy actually increases by 27%. Now, this poor accuracy stems from the following issues. So as I explain later on, we had to use a different data set, which the pre-trained model was not trained on, which will explain the lower accuracy in both the regular data set and the augmented data set. And when we use the entity switching code, it doesn't properly switch the entities, which I'll explain later on. And so we were left with a lot of name mismatches, which led to a much lower accuracy in the augmented data set. Next slide. So first we have our minor issues and hotfixes. The initial chosen dataset we had full sentences, but then the entity switching code used by the paper required input sentences to first be parsed in a certain format, which included tokens attached to each word. So instead of using the initial dataset we chose, we decided to use a pre-parsed dataset called CONLL 2003. Next slide. And the next really big issue we faced, which tanked our accuracy, was that the entity switching code, although it effectively switches entities for a single document, it doesn't do so simultaneously for multiple documents, which leads to different name orderings in different sentences, leading to leading to several sentences being marked as incorrect in the evaluation. And we'll solve this issue in the following manner. Next slide. So since our main issue was that the data used was incompatible with entity switching, and the switching code didn't work with multiple text, we simply need to use a different data set and make our own entity switcher. So what we're going to do is make our own toy data set as a proof of concept and make our own entity switcher. Since the purpose of this project is simply to mitigate gender biases in gendered language translation, it will suffice to simply use sentences of simple form, like person in a profession, and the entity switcher can be implemented very simply using this format. And next, we'll move on to the improvement approaches.
So the first improvement we plan on inculcating into our project is to modify the data set such that there is a male ID, arbitrary string of characters, which is used to encode gender information of a sentence. And basically we supply this token before the training begins and then take it out of the sentence when the output is generated. And this helps us in increasing the accuracy of our model. So yeah, this is the first improvement. And for the second improvement, we change the evaluation metric. And we present this improvement because the paper presents a problem where gendered languages often have a subject-verb disagreement when we switch entities, when we switch genders of different words. And changing the gender of different words also means that we have to change the preceding nouns, preceding verbs, especially in German. And hence we also need to have an evaluation metric for our entity switching method that takes into account not only the noun of the sentence, but also the sentence level representation itself. However, this would require a person proficient in the language or automated grammar checking to see how our switch entity method actually does in this aspect. We'll next move on to other parts of the improvements.
The third improvement approach will be probably called extended entity switching, because it basically is applying the entity switching method not just to personal names, but also the nationality and racial related terms. Our rationale and intention for doing this is basically mitigating the nationality related bias, which not just stems of the limitedness of the data sets used, but also the fact that some terms, especially adjectives and verbs, have double meanings, where one is positive and the other is negative. For example, for a more concrete illustration, let's take a look at this example. A Russian man collaborated with them. Machine translation of this sentence into Chinese can possibly translate the word collaborate to one of these verbs, like cooperate or collude. And if the translation used is the verb collude, this negatively, this for no reason attaches the negative sentiment of collusion with the nationality term Russian. And our purpose by applying this approach is to mitigate this bias. And the next improvement approach is, next slide. The next improvement approach involves the shortcoming of the templates used in building the datasets. The fact is that the templates used in the construction of the datasets are based on a very short, limited number of personal names, adjectives, and occupation terms. Like in more concrete terms, about 30 adjectives and 30 occupation terms have been used in building the templates, which can result in impeding the generality and robustness of the models built using these datasets. So what we are doing in this case is increase significantly the number of adjectives, personal names, and occupation terms used in building the templates and naturally the datasets, which is expected and highly likely to increase the quality and robustness of the models built using these datasets. That's it. Thanks for listening.